So today I'd like to try and explain, as just mentioned, a little about Toyota Motor Europe and also the way we're approaching lean and green. So just as a way of introduction, Toyota Motor Europe, obviously Europe sounds that we're just covering the EU. We don't. We cover a greater Europe. We go into Russia, Kazakhstan, Georgia as well. So actually we have 9 manufacturing plants within that territory. We have 14 parts distribution centres. We have 30 sales and marketing companies which are responsible for delivering the final car to the customer, and indeed we are selling to around 56 different countries within that, and of course many of those are of different languages as well. Myself, I've worked at Toyota for 26 years. I joined Toyota in the UK at the manufacturing site at Burnaston during the construction phase. My first job, even in 1991, was manager of facilities and environment. So you can already see that we have quite a long-term view. So why are we here today? So actually you can see there that we are facing as a globe a population increase. We're seeing also an increase in wealth, but on the negative side, that's a resource depletion, and also climate change and air pollution is also becoming a concern. Michael's already expressed that a little bit, but if you permit me, I'll just put some figures on that just to try and give you the context and the size of the problem. So today we have around 7.5 billion people within the world. That's expanded already by many times, as you can imagine. But actually, it's predicted to increase again. Anybody like to hazard a guess what the UN thinks in 2050 will be? 11? Right, it's actually, yeah, it's 9.7, I think, at the moment from what they said. But it's a big increase in population. But also we see that within that, people are becoming more aspirational as wealth increases. We see countries that we formerly thought of as developing countries, they are now coming to the fore. We see China, we see other countries, India, etc. And there is an expectation as wealth increases that people can enjoy the benefits of the middle class that we may think of in Western Europe. Actually, what will that mean? So that means that actually the OECD is predicting that the middle class will actually double by 2030. This disposable wealth will then actually materialize itself in many ways. Many more pieces of equipment that we might wish to use, but also it materializes itself in the terms of the transportation and the desire for mobility, and also as a personal mobility, but also the desire to move things around the world, as Michael put in his graphs. In terms of resource depletion, the OECD is predicting that energy demands will increase by 37%. Despite all of the energy saving that we're trying to do, it's going to increase by 37% by 2040. And also, in actual fact, for water, which is more critical for human life, of course, demand will increase by 55% by 2050. These are very big numbers, and this is one of the reasons that we need to think about this. But of course, all of these things that we might wish to use, the material possessions and what have you, also look at other materials as well. And we are depleting those faster than the Earth can actually replace them. So who's heard of Earth Overshoot Day? Anybody? Okay. So Earth Overshoot Day is the day, in theory, when we've used 1 year's worth of materials, and for the rest of the year, we're borrowing from the bank, effectively. Anybody hazard a guess as to what date the Earth Overshoot Day was this year?
About a month ago?
Yeah, that's correct. It was the 2nd of August. So we just made it into the 8th month of the year. But that still means that we're using much more resources than actually the Earth can actually regenerate. And unfortunately, despite the Paris Agreement, we're still seeing a battle with climate change, and that's now moving in also now into air pollution as well. So increasing public perception about that. And of course, all of those things I've mentioned there, they're really important to the transport industry and mobility industry, and therefore to us as Toyota, who are manufacturing predominantly passenger cars. So I'd like to take you on a little journey about how Toyota has actually managed this during the course of the past years. So actually in 1963, this was one of the first activities that Toyota recognised, and that was to establish that the environment was an upcoming problem, so a lot of forethought, and they pioneered, probably in our industry at least, a first environmental committee, which was in 1963. And this was really to orientate all of the divisions, which, as you can imagine, in a big organisation are vertical, they're very strong, and in those days, probably they didn't work together so well. So the Environment Committee was a horizontal type of organisation, which was able to bring those people together, get them talking about a subject that was maybe quite far off in the distant future, but needed collaboration and work together. In 1973, skip forward by 10 years, we started to think that the company's getting organised now. How do you start to actually win the hearts and minds of people, the members that work within our organisation? And one of the things I've found over the years is that actually it's not a scientific or an engineering problem in total. There's a lot of psychological issues that we have to face in persuading people that we need to change or to move. So we started what we call our Green Month campaign. In June every year, all of the affiliates in Toyota globally will actually take 1 month where they focus a little bit on education, information, activities around the plants and around the sales companies to try and raise the awareness of individual people within the organisation, educate them and try to win their commitment. Skip forward again, 1992. So by coincidence, this was just a few months after I joined the company, and it wasn't my plan, but there was the first environmental Earth Charter that was actually conceived. This is actually for the first time where we really codified our activities and actions, and we released this now to the world. We actually said to the outside world that this was going to be a challenge area that we wanted to work on. And along with the charter came a policy. And then it also started in a typical Toyota fashion that we would start to have midterm plans, 5-year horizons, which we would actually start. So that started in 1992. And as I said, the communication to the external stakeholders. 1993 actually then was one of the first things on that action plan for the product side. And actually a project was conceived called G21. And actually what that meant was a program to develop a new vehicle for the 21st century. And the person who actually received that challenge ultimately was a gentleman called Uchi Yamada-san, and he is now our chairman of the company. And he received a request from the board, and they said, please design this car. We give you carte blanche. You can do whatever you like. But you need to challenge the conventional. You need to take some pioneering activity. So amongst great secrecy, actually, the project started. And the evolution of that project culminated in 1997, which coincided with the Kyoto conference, the first COP3, where the Kyoto Protocol was born. And actually that materialized itself as the Prius, the first generation Prius. This was the first hybrid electric vehicle. And you can see this was really the start of the road to electrification, at least for Toyota. That vehicle was launched in '97 in America and in Japan, and then finally in 2000, in time for the 21st century, it was launched in Europe. Skip forward another few years. We're now at 2015, and actually this is the celebration, shall we say, internally of 25 years of action planning. So we'd had 5 action plans at this time. And one of the fruits of that activity was the Mirai. It's been mentioned already. It's the first hydrogen fuel cell electric vehicle sedan, which is put into the commercial manufacture. You can see a number of them running around. Michael had the chance, and myself had the chance to come by taxi to this venue in a Mirai. The work on this took an enormous amount of time, long thinking, long planning, long R&D, around 25 years of activity. So this is one message to get across, that it's not an instant fix. We can't just do something very quickly. Actually, we need to have a degree of planning and meticulous work. We want to bring a product to the market that works smoothly, works to the expectation of the customer, will start, for example, in Finland when it's minus 20 degrees centigrade without any problem. But also 2050 gave us a chance to reflect, 25 years of activity, and suddenly you need to think, well, what's coming next, effectively? So we were challenged by top management to really think about this quite deeply, and what should we do, and what was going to be an effective way of managing. So what we started to do was actually imagine what the future would look like. So actually what we tried to do was envisage a sustainable society, and that sustainable society we figured should be considered in a reasonable long term, but a term that we could actually imagine how we could progress towards. So we pictured 2050. Michael's already shown the pictures a little bit, but the symbols here. But we came up with 6 grand challenges. So these are challenges that are not only facing Toyota, but are actually affecting our sector and also affecting society in general. And they try to reflect a little bit all of those issues that I mentioned in that very first slide. So here for challenge 1, 2, and 3, we're looking at the carbon dioxide emissions. Challenge 4 is looking at water. Challenge 5 is looking at the circular economy and recycling society. And challenge 6 is looking a little bit different. It's looking at challenging a society that can live in harmony with nature. So in terms of challenge 1, we talk about the product. And here we've set a target that we want to go towards a zero CO2 vehicle for all of our fleet. For challenge 2, it's about the whole life cycle outside of our direct operations. So, for example, the CO2 that's embedded in our supply chain, in our logistics chain, and onwardly also in use when you guys are driving the car. And then finally, what happens at its end of its life. Challenge 3 is all about actually what we can directly control within our factories. Challenge 4 is about how we can actually optimize and minimize the amount of water that we're using within all of those stages of the life cycle. Recycling is about designing our cars in a good way so that at the end of the life the vehicle can be recycled in a good way. And then we'll come on to challenge 6 a little bit later on. We had a mission statement, and some key words that came out of that mission statement for us was we wanted to have this grand idea of having and achieving a net positive impact. We also realised that actually all of these challenges are beset with difficulties. We don't know exactly how we're going to achieve these targets. But actually we're putting them on the wall, we're putting them on the paper. We're thinking about actually visualizing what those problems are. And if you are familiar with the Toyota production system, the first thing to do is visualize your problem. But also we're committed to making sustainable development, but we're recognizing we have to do this together with society. We can't do this as an individual company. We can't even do this as a sector. Even if we're going towards fuel, for example, we need to have very good partnerships with fuel companies. So what did we do? We had this 2050 challenge that was out there in 2050, obviously, but then we had to bring it back, land it into some realism for the short and medium term. So we did what is called backcasting. Actually, it's the opposite of forecasting. So we'd forecast right to the front, and now we're backcasting back and thinking about the milestones that we may need to achieve on the route to 2050. Otherwise, do we know we're going the right direction? So we bring it back through 2030, through mid-long-term visions, and then we bring it back into our next 5-year action plan, which will run from 2016 through to 2020. That plan covers 3 basic areas. It says that we want to make a contribution to a low-carbon society. We want to have a contribution to a recycling-based society. And for that, in Europe, you can read the word circular economy. And then we also want to have environmental protection and also contributing to this harmony with nature. It's all based, though, upon environmental management. So a key part of our activity is that we've got strong environmental management at all levels within the company. And for what that actually means for us is ISO 14001. It means that all of our factories, our TME, headquarters operations, all of the distribution of parts and of vehicles, and now all 30 of our distributors are certified to ISO 14001. And now we are progressively moving down towards the dealers, which are often nearly in the main independents, and we're asking them to have environmental management systems of some type. So we bring all of these things together, and you can see there, I think you can see we're gearing up really towards a 2050 challenge there. So our activities that we're doing today will have an effect up to 2050. So, how to explain what we're doing and how we're doing it? I'd now like to try and use the life cycle to try and explain that, and the life cycle of the car in particular, of course. So here you can see a typical representation of the life cycle, and generally speaking we recognise these 6 stages as being critical to the life cycle of our product. One is the research and design, one is the operations, actually making the vehicle, all of our suppliers making the parts, the logistics, both inbound to the factories and outbound towards the customer, the use phase, traditionally very important. 85% of the CO2 impact comes from the owner, that when he's actually putting his foot on the gas pedal or on the brake pedal. So that's the traditional use phase. End-of-life vehicle recycling process is mandated in Europe, but of course we still have some very tough targets, and we also have some very high aspirations in this area. And then moving forward into recycling that back to the new vehicle is the intention. So this is the area that we will try to cover. So if we look at the design phase, and from my point of view, we're looking at these challenges. So challenge 1, which is the CO2 of the vehicle emission, challenge 2 about the life cycle, challenge 5 about the circular economy, and challenge 6 about nature as well. So what do we put into the design of the vehicle? A couple of the points were raised by Michael as well, but we're trying to find environmentally friendly materials. So materials which are plant-based or can come from this type of source are gradually being involved and incorporated into the car. Of course, we have to make sure that we satisfy you, the customer, for the feel and the touch of those parts, and that they're reliable and they're strong and durable. However, we also have to satisfy many regulations as well to make sure that those parts will respond correctly in an accident or something like that. The design also should consider the end of the life cycle when the car is being recycled. So actually we've included in here some elements which are easy to dismantle, and we actually put a mark on those to help the dismantlers who are actually doing that process of dismantling the vehicle. Actually, how do they easily take the car apart to allow recycling? And this is where we will try to avoid composite materials, so that a big piece of plastic, for example, is basically PP and it will go into the correct recycling chain. But also from the design side, of course, we are thinking about the fuel sources. It's one of the most important areas of the design, particularly as regulation is driving us. And please remember, it's also a global regulatory situation as well. So we are a company that happens to be based in Japan, but actually we're selling vehicles all over the world. So we have to manage all of the types of regulation for tailpipe emissions in every country of the world. So actually, we are relying very much on the Prius Generation 1 as our halo vehicle, and it's bringing forward technology. And that technology is hybrid technology. And you can see here that from a primary energy source, hybrid technology can connect us to all of those primary energy sources, whether that's oil in the traditional way, natural gas, materials made from coal or whatever, but also, of course, increasingly renewable energies, and electricity is becoming to the fore right now. And of course, the one that we want to bring to the party as well is about hydrogen, because we believe this is a very important primary energy source that we can use, or energy carrier, shall we say. Here is the family tree. So right down there, the root, the seed at the beginning was the Prius Generation 1. Actually, you know, as a company, we probably made no profit on that vehicle for 10 years. Can you imagine going to your board and saying, I've got a great idea, here's a product which is not going to be profitable for 10 years. And you're going to have to subsidise it. Yeah, that's the truth of the matter. It's the long-term nature of the management thinking that allowed us to get to this stage. 16 models, which is the largest lineup of electrified vehicles by any manufacturer in the world. And they're all hybrid electric vehicles that you can see on this picture. Of course, the Mirai is a hybrid electric vehicle. It's just that its fuel source is hydrogen. Operations and logistics, an area that you're probably familiar from studying Toyota. You can see we're covering all of the challenges except the design of the vehicle effectively here. Here's a very simple viewpoint of the actual production process. We're including here the inbound and the outbound logistics as well, because these are important for our consideration. We're considering the raw materials and also the parts that are coming from our suppliers. So any of you who are familiar with CO2, it's scope 1, 2 and 3 here. This is the performance to date. So this is just for energy, and I'll just explain the graph and show you some other graphs as well. So on the left-hand side is Toyota's performance in 2001. Why 2001? This is when the second factory in Valenciennes joined the family. So we actually, instead of just having one factory, we now had two factories to add together. And on the right-hand bar, you can see the 2016 performance. And you can see how we've improved. And that even includes the addition of other factories, including unit plants as well, which produce either gearboxes or motors, engines to the party. Because the actual unit here is per vehicle produced. So even though we're increasing our vertical management chain there with including those other components, we're adding energy but not getting any additional vehicles as such. What you can see there as a line at the top is the average of all of the OEMs in the EU 28. And you can see we're significantly below their performance. Same story for CO2. In fact, actually, the plants in Europe of ACEA don't even achieve what we were achieving in 2001. In terms of water, you can see here the big lead. And for VOC, or COV, I guess, in French, is for the volatile organic components from the painting shop predominantly. You can see again, even though we're not probably using the most expensive technologies, the way we manage those technologies on daily Kaizen basis and daily improvement means that we can achieve much better than the industry average. And here is waste as well. So actually the waste line for the industry average goes up at the top there, nearly disappearing into the above graph. This is waste, which is total waste, but we exclude scrap steel because some scrap steel, of course, is designed to be returned back to the supplier because we have to stamp out the parts. But in terms of how do we do that, just two examples that I'll bring to you here, but there are many more. Maybe we can explore them in the Q&A. Rainwater. So TMMF is our lead plant. TMMF, sorry, is the plant in Valenciennes. It's the plant that is leading our benchmarking within the company as a global organisation for water usage. And what it's doing actually, it's minimising the amount of water used in production. When it comes out and the water has been used, we try to clean up and recycle as much of that water as possible. So you can see here that the makeup of the water is 40% of what we put out at the end of the factory is actually going back into the factory. And the water that we're putting into the factory to make up that deficit is coming from rainwater. So assuming a normal pattern of rainfall in a year, we managed, I think it was only 12 production days where we had to take water from the municipality to actually operate our plant. That is a record as far as we're concerned within our organisation and probably within the industry. On the right-hand side, you can see the efforts that we're making to use solar energy. This is a partnership with a third party, so this is about the collaboration. They paid for and built the solar park on our property, and the electricity is absorbed into our grid and we utilise it in our factory. And the amount of electricity, even in the UK, which is not really famed for its sunshine, is 5%, and it is a viable activity, shall we say. And that's equivalent to making around 7,000 vehicles a year. In terms of use, well, we can have a look at that. So here is one of our eco-concessions. I chose one of them that's based in La Rochelle in France. It was designed to be a lean, green building at the starting point. It's involved many technologies and a lot of investment by the dealer. This is a private dealer who's done this because he's selling Toyota hybrid vehicles, and he wants to show off the green nature. And this is what we're trying to encourage within the organisation. So as we are starting to refurbish the network, this is the way we shall start to be going. You can see many technologies on there. Just at a glance, you can see the solar panels over the parking area. You can see LED lighting in here on these pictures. You can see a green roof there. You can see the design of the building has an overhang to prevent solar gain during the hopefully hot summer days. Water is collected for the car wash. Actually, air that's brought into the building for air conditioning is sucked through a Canadian well, which is built underneath the building to actually improve the air quality going in. So what have we done in the sales area? Well, over these years, greater than 1.5 million cumulative hybrid vehicles sold in Europe. So please think about that against some of our competitors who are struggling to come into the electrification market. Actually, what that's done is it's brought our new car CO2 average, this is the target that we're given by the European Union, to 105.47. We're one of the top runners within that area, but with a complete range of vehicles, right from the very small to the big 4x4 vehicles, which we still sell within that calculation. Actually, up until September 17, 40% of our sales volume now is hybrid vehicles, and that can go as high as 50% in Western Europe at this moment in time. Our newest vehicle with the hybrid technology in the Toyota range is the CHR. It's built in Turkey. Our current order for that, 77% of them will be hybrid. And actually, if you start looking at some of the other figures, we're nearly 50% of the alternative fuel market is Toyota. And actually, when you look at it a little bit deeper, 50% of that is hybrid vehicles. And when you calculate what our percentages of that, it's greater than 90% of market share. So that's, you can see we're dominant. It's coming from this pioneering approach that we've taken over the years. After sales and service, we talk about extending the life. So the green circular economy is talking about how to make product last longer in the market. For a car, can anybody hazard a guess at what the average age of a car is in the whole of Europe when it goes to the scrapyard? Any ideas? No, it's between 14 and 15 years. Actually, how many owners will that car have had? It's between 5 and 6 owners. You can say that our car is very recycled already. How many owners will this have? How long will it last before the new generation takes it away? So the thinking way is it's one of the biggest investments that a person ever makes within his life, and actually we're making that car go and last a lot longer as well. How do we do that? Well, for hybrid, people are concerned about having to replace batteries. Actually, I have a problem. I don't have enough batteries at the end of life to put anything into second use at the moment, because even though we've been selling cars since year 2000, I get very, very few batteries back. One of the reasons is the durability and quality of the battery. They don't fail. and actually to try and reinforce to the customer that he has no risk. He's not going to face a bill, even if he buys a second-hand vehicle. If you bring the car in to the dealer and he has a health check on it, free of charge in most countries, we will extend the warranty of the battery for 1 more year. This is encouraging people to have confidence in the electrification technology that we're using. But to support the vehicle, of course, lots of parts are needed in it for crash damage or just general repair as well. And we stock in around 265,000 parts, and a greater than 500 of those part numbers are actually remanufactured parts as well. So they've actually lived once and they've been remanufactured for car use. End of life. Important, of course. All remember when you used to go down the railway line and you'd see all of the car yards on the back. So this is the typical process. There's a depollution phase where the car is dismantled. Some parts are taken off because there's customer orders already for some parts. Some parts are targeted for recycling at this stage. Vehicle then goes to be shredded, basically pounded up into many small pieces. And then this is one of the important technologies, is post-shredder technology, where we try to extract all of the materials. We did a shredder trial on some of our vehicles, all one model, which had been into a trial with the European Union, and we had to scrap them at the end of their life, and we were able to achieve 96.9% material reuse and recovery. So that does include a small amount of recovery to energy. So this is against the ambitions of the European directive at the moment of 95%. To do that, we've, in the past and continually, we have been developing the technologies about recycling. We don't just think about building the car, but we started hybrid battery collection systems. Even in the factories, carbide tools, which are very expensive, we're able to recover and recycle the materials there. In 2012, we had a world first because we're able to actually separate the magnets that are in our strong motors and actually get back to the rare earth materials which are being used, and that can go back into new magnets. And then hybrid batteries as well, remanufacturing and reuse operations have commenced globally. Now, all of these things are technically feasible, but also they're not always economically feasible at this moment in time. So country by country and the region by region, we're having to consider how to improve this situation. Bigger picture, well, Challenge 6, as I said, is about looking at how we combine with nature, and one of the things is we need partnerships, we need to work with others. And there's 3 basic projects that the company's working on. One is about how to use our facilities and making those little green oases, making them biotopes. But also the second one is how do we support some of the bigger projects in the world, the aspirations of society. And in this area, we're working with the World Wildlife Fund on sustainable rubber production. The IUCN Red List, which you may know, is the list up of all of the threatened species. Royal Botanic Gardens and Kew are supporting that by looking at the plants. And we work on a more technical side with organisations such as the World Business Council for Sustainable Development. And more latterly, we're pushing our view and our contribution into the hydrogen area as well. And that has actually included us releasing around 7,000 patents for other people to use free of charge. So we don't just keep our technological knowledge to ourselves, we actually try to share that as well with others. Last slide, and it's just showing a little bit where we believe a future society could be in terms of energy and the transport sector. So you see on the right-hand side the traditional types of fossil fuels here. Obviously, we're contributing with hybrid vehicles. So globally, the estimate is our hybrid vehicles have saved something like 77 million tonnes of CO2. That's the estimate done by our colleagues in Japan. However, we're increasingly considering renewables. So I heard just today on the radio before I came in that the UK in August achieved just over 50% of all of the energy supply came from renewables. And one of the things they were already flagging up is, how do we store this energy when there is a surplus of energy? We have a solution. It's actually making hydrogen and putting hydrogen into a form where it can be stored very easily. So it is a complementary, not a replacement, but it's a complementary activity to all of the discussion that we're having about battery storage, for example. In terms of the electricity grid, we all know that there are some compromises on there. If everybody goes to an electrical vehicle, maybe we'll have problems with the way that electricity can be actually distributed and the demand managed in such a way. In the village where I live, if two people want to put a Tesla on their drive, that's it for the whole of their street. It's fact. So please, take thought that there are consequences by some of the decisions that are being taken by governments and what have you in particular ways. We're proposing that the hydrogen grid can be a very key part. We can make hydrogen cleanly with renewable energy, we can store it relatively simply, we can transport it, we can even transport it in pipes under the ground. There's a city called Leeds in the UK. It's actually got a feasibility plan to take away natural gas and deliver only hydrogen to the domestic houses, to the retail, and therefore it will be easily available for the fuel station by the side of the road. So hydrogen society can be really an integrated part and a very powerful contributor to decarbonisation. And you can see that actually transport here, we're talking today about the fuel cell vehicle, the Mirai, but actually we're working on fuel cell buses. This is a fuel cell truck for long distance transportation. There is a prototype of that in the US now, and there's a company called Nikolai, which is making fuel cell trucks for long distance trucks for the US market. Fuel cell train. I know that colleagues are here from SNCF today, but this train is being made by Alstom and is on test at the moment in Germany. And the idea is this will prevent the rail network having to invest huge amounts of money on rural lines, but still achieve zero CO2. And even a fuel cell boat. So this yacht is a converted catamaran, and it's now sailing around the world with the support of Toyota France, and it's promoting the use of hydrogen as a potential source of fuel for the future for society. So I think we're gearing up for 2050. The question is, are you?